Welcome to this project. In this section, we are going to introduce the AI Coding Trainer, an AI-powered full-stack application designed to help us practice coding in a more guided and interactive way. Most coding practice platforms can tell us whether an answer is correct, but they usually stop there. What we want instead is something closer to a real mentor. That means generating problems based on what we want to practice, checking our code, and then explaining what went wrong and how to improve. With this app, we choose a programming language, a difficulty level, and a topic. Then the AI generates a coding quiz with starter code and a hint. After we write our solution and submit it, the backend runs our code safely, and the AI evaluates it, gives feedback, and shows a sample answer. So the goal of this project is not just to test our code, but to help us learn faster with clear guidance. In the next part, we will walk through the application and see how the full workflow works. Let's get started. Now let's walk through the final demonstration of the AI coding trainer. We start with the default settings: Python, beginner level, and loops. Step 1, we generate the problem. The system produces a beginner-friendly coding task. We carefully lead the problem statement to understand the requirement. Step 2, we check the hint tab. The hint provides guidance without revealing the full solution. This supports learning while still encouraging independent thinking. Step 3, we write our code in the editor. In this example, we intentionally make a small mistake, using range 1 to n instead of range 1 to n plus 1. Step 4, we click Submit. Now we review the AI feedback. The system gives a structured evaluation, a score, a mental summary, identified issues, suggested improvements, and a detailed explanation. It correctly detects the off by 1 error. Next, we check the Output tab. We can clearly see which test cases failed and why. The expected and actual values are shown side by side. To confirm the reasoning, we return to the AI feedback again and review the explanation carefully. Now we improve the code. We modify the loop to use range 1 to n plus 1. Then we submit again. This time, the feedback shows a higher score and all test cases pass. Finally, we open the Solution tab. We compare our implementation with the model solution and confirm that our logic now aligns with the expected answer. Now let's review the JavaScript version. One of the key strengths of this platform is that it is language agnostic. When the user switches from Python to JavaScript, the entire AI pipeline adapts automatically. The selected language is sent to the backend and included in the structured prompt to Gemini. This means the generated problem is rewritten in the JavaScript context. The starter code uses JavaScript syntax. The evaluation logic expects JavaScript conventions. And the AI feedback analyzes JavaScript-specific structure and style. In this example, the student implemented a correct solution using a standard for loop. After submission first, the execution engine runs JavaScript test cases. Then Gemini performs qualitative analysis of the code. We again see a 100% evaluation, along with a mentor-style summary confirming correct logic, proper loop usage, correct variable handling, and edge case handling. And just like in Python, the AI still suggests potential improvements, such as using a mathematical formula for efficiency, while acknowledging that the requested approach was followed. The intelligence layer is not tied to a single programming language. Gemini understands syntax, structure, and best practices across languages. So the same AI coding trainer can scale to Python, JavaScript, C#, Java, and more. Now let's take a look at how the AI generates tasks at different difficulty levels. First, the beginner level. Here we see a simple loop-based problem such as summing odd numbers. The logic is straightforward. It focuses on basic control flow, loop structure, and simple condition checks. This level is designed to reinforce core programming fundamentals. Next, the intermediate level. Now the complexity increases. The problem combines multiple concepts, for example, Fibonacci sequences and prime number validation. Students must manage nested logic, helper functions, and more structured thinking. It's no longer just about syntax, it's about algorithm design. Finally, the advanced level. Here we see a more complex task, such as generating a spiral matrix. This requires state management, boundary tracking, and multi-directional traversal logic. Students must handle edge cases and think carefully about loop invariance and matrix indexing. This comparison shows something important. The AI does not simply generate random problems. It adjusts complexity based on level selection. Beginner focuses on fundamentals, and intermediate combines multiple ideas. Advanced requires algorithmic thinking and structured problem solving. So the AI coding trainer is scalable and adaptable to different learner stages. This demonstration highlights the complete learning cycle. Generate, attempt, submit, analyze, improve, resubmit, and validate. The AI coding trainer is not just grading code. It is guiding iterative improvement, reinforcing concepts, and supporting structured learning. If you want to master that workflow step by step using Google Antigravity, I break down the entire process inside my full course. The link is in the description. Alright, thank you for watching this video, and I'll see you in the next build.